Alrighty, so we want to solve this inequality. It's an inequality because there's a greater than sign there. And we solve it just like any solve. We're going to get rid of this first. And then we're going to get rid of that 3 second. So to get rid of the minus 11, you're going to add 11 to both sides. That's going to disappear, leaving us 3 times 4 to the some power, x power, is greater than 12. Next step, I want to get rid of that 3 in the front, so I'm going to divide both sides by 3. That's gone. So I now have 4 to the x power is greater than 4. Now some of you could look at that and go, 4 to what power is greater than 4? Oh, isn't that going to be a 1 if they're going to be equal? Yes, you could see the answer right here. You can kind of see what's coming. But I'm going to go with logs just for the sake of logs is where we're going with these kind of problems. So what I'm going to do here, I want to change this to a log. So this is log base 4, and you put the x over here. The question is, what do we do with this? We're normally used to equal signs. Well, since this is greater than, and it's open towards the x, it's going to follow that we're going to have it like this. The inequality is going to flip. The reason is, isn't it open towards the x? And when the x goes to the other side, shouldn't the inequality follow it as it goes to the other side? So this is an answer. The problem is, what does this equal? Well, what that log right here is saying, what this is saying right here is really saying 4 to what power equals 4? Oops, I said 1. I'll give you the answer. 4 to what power equals 4, and the answer is 1. So really, this is 1 is less than x, which I don't like that notation, and you'll never really see that notation. You would always see it as x is greater than 1. So the red is an answer, but you would never see it written that way. So that would be the answer. Anything bigger than 1 would make this true. Now let's check to make sure our inequality didn't do some weird turn and we messed up on our inequality. So let's choose a number bigger than 1 to test. Something bigger than 1 might be 2. Okay, I'm going to check x equals 2. So it's 3, 4 to the second power minus 11 is greater than 1. We're seeing if this is true. So 4 squared is a game as a kid, but we're talking about 4 to the second power, so it's 16. All right, so 4 squared is 16. And can we pause right there and just go, okay, 3 times 16 minus 11, is that going to be bigger than 1? I don't even have to finish it. Can you tell this is going to be bigger than 1? I hope so. So we're like, yeah, I can see. I'm not going to finish it. I can see this is going to be bigger than 1. I can see this is going to be a true statement. I can see that we're on the right track. So the inequality didn't get lost in the problem. Alrighty, to solve this equation, we're going to get rid of that 4 first. So I'm going to minus 4 from both sides. I now have, that's all screwed up. We will get negative 1 in front. I like to keep that as a negative 1. It makes a little bit more sense there. Equals 10 minus 4 is 6. Then I want to divide by that negative 1. Get rid of it. Flip your inequality, your equal sign. Just kidding, you can't do that. So you divide by negative 1, so you just get this right here is negative 6. What I said right there is, if this is an inequality, you would want to flip it. But since it's an equal sign, you don't have to worry about flipping it. So you simply are right here. We want to solve this as a log now, because you can't really look at that and figure it out. So we have log base 5 negative 6 equals x minus 8. Now, technically, you should pause and go, I can't have negatives and logs. I'm done. The answer is undefined. Technically, you should stop up here and say, how am I going to take 5 to some power and get negative 6 out? I'm done. So some of you could stop right here and be, I'm done. Some of you can stop right here and say, I'm done. But if you couldn't, you could just keep going also and just realize at the end, add 8 over. So I now have x equals 8 plus or minus log base 5 negative 6. So what you could do is you could go all the way to here and get x equals this and realize 8 plus an undefined is undefined. And you find out your answer is undefined. Because no matter what you plug in, it doesn't work. So we could test it. How do you test it? Try any number you want. None of them are going to work. So choose any number and it will not work. And that will be your test if you want to see if it's actually undefined. To solve this inequality, I'm going to first get rid of that 7 right there. So I am going to minus 7 from both sides. That's gone. So I have negative 2, 8 to the 3x power is less than or equal to negative 6. Next, I'm going to divide by the negative 2, both sides. Once I do that, I have 8 to the 3/6 power. I have to flip the inequality because I divided by a negative, and negative 6 divided by negative 2 is positive 3. Now, when I look at this, this makes no sense to me, so I need to change it to a log. So as we change this to a log, I get log base 8, 3, and then the 3x is over here. The question is, what happens to the inequality? Well, since it's open towards the x, don't you want it to be open towards the x? It follows the x. So it's going to go that way. It's going to flip. Because it's 3x greater than or equal to, so I want the greater than facing the 3x. I got moved to the other side. Next, I want to get rid of that 3 right here, so don't do a divide by 3. Both sides. That's gone. So I now have x is greater than or equal to, because I'm reading backwards, log base 8, 3 divided by 3. So that is an answer, but it's not the best. Let me write it a better way. I always like to put x first, and that'd be greater than or equal to log base 8, 3 divided by 3. That's the better answer. Now, how do you check this? That right there is a little tricky. Because if you don't know what this equals, you can't really check it. But 8 to what power is 3? 8 to what power is 3? Can you tell that's possibly a decimal? So a decimal divided by 3, isn't that going to be another small decimal? So I could say, oh, this is some sort of decimal. So if it's going to be bigger than some decimal, what's a number bigger than some decimal? 1 or 2? Now, if you still struggled, I didn't know that was a decimal. Could you just plug in 5,000? Or could you put in negative 5,000 and test? Doesn't matter what you're choosing. You're just choosing something on one side or the other. So if I doubt this is going to be 5,000, let me check 5,000. Put in some random check number. If I check x equals 5,000, I got negative 2, 8 to the 3 times 5,000, so that would be the 15,000 power plus 7. Is that less than 1? Let's pause and think about that. Isn't this going to be astronomically large? Times a negative. So isn't this going to be a really huge negative plus 7? What's a really huge negative plus 7? Is it going to be less than 1? A really huge negative plus 7, is that going to be less than 1? Why, yes, it is. So we're good. We wrote it right. We wrote it right. Because we chose a number greater than what we thought. 5,000, we think it's on the greater side. So I chose a number way bigger than this. And it came out true, so my inequality is in the right direction. So we want to solve this equation right here. Equations are easier than inequalities. First step is, for this equation, is to add the 1 over. So we now have 10 e to the x over 7 is equal to 20. Next step is to get rid of the 10 in front, so divide it off. Do it to both sides. So I now have e to the x over 7 is equal to 2. Now I want to change it to a log. So I have log base e, 2, equals x over 7. All right, now how do you get rid of that 7? Well, it's divided by x. So to get rid of a divide, you're going to multiply both sides by 7. So I now have x equals 7. And log base e is actually ln. So there is my answer. Now you could also write it like this. X equals 7 ln 2. It's probably a little bit better way to write it. They're both the same. There's an or there. They're both fine. But you usually put the 7 in front so you don't think it's inside the natural log. And make sure you don't leave log base e, because the ln is a very kind of important way to write it. Now, to test this is a little tough. So we're not going to go around testing this right now. We're not to that point of being able to test this kind of answer.